For thousands of years, people believed they knew exactly where the Punjabi people came from. Ancient legends, old textbooks, and generations of oral history all told a fairly simple story. Then, scientists cracked open a set of 5,000-year-old bones, pulled ancient DNA out of them, and discovered that almost everything we assumed about the deep ancestry of Punjab was incomplete, and in some cases, flat out wrong. This is not folklore. This is not speculation. This is hard genetic evidence, pulled directly from skeletons buried thousands of years before anyone wrote down a single word of history. And once you hear what researchers actually found buried in that DNA, you will never look at the story of Punjab the same way again. To understand why this discovery matters so much, you have to go back to one of the greatest ancient civilizations most people barely learned about in school. Long before the pyramids of Egypt reached their final height, an enormous civilization was quietly thriving across what is now Pakistan and northwest India. Historians call it the Indus Valley civilization, and at its peak, it was home to some of the most advanced cities on the entire planet. These cities had organized street grids, complex drainage systems, public baths, and standardized systems of weights and measurements, all built thousands of years before most of the ancient world figured out basic urban planning. For over a century, archaeologists dug through the ruins of this civilization, uncovering pottery, jewelry, seals, and skeletons. But one crucial piece stayed locked away, hidden inside the bones themselves. Nobody could successfully extract usable ancient DNA from the remains, largely because the hot, humid South Asian climate destroys genetic material far faster than colder regions of the world. That changed when researchers finally managed to extract a usable genome from a woman buried at Rakhigarhi, the largest known site of the Indus Valley civilization located right on the border of modern Punjab and Haryana. She lived roughly 4,500 years ago, and her skeleton had been sitting in the ground since long before anyone in the region spoke Sanskrit or wrote down a single verse of ancient scripture. After years of failed attempts, scientists finally pulled a clean genetic profile from her remains, and what they found reshaped an entire field of research. Her genome revealed something researchers were not fully expecting. She carried a mixture of two major ancestral components. The first was related to ancient Iranian populations, though notably not from farmers who had already adopted agriculture in Iran itself, but from an older related lineage that split off before agriculture even spread through that region. The second major component came from ancient hunter-gatherers connected to populations found across South and Southeast Asia. Scientists refer to this ancestral group using the term Ancient Ancestral South Indian, often shortened to the acronym AASI. Combined together, these two ancestral streams formed the core genetic identity of the people who built the great cities of the Indus Valley. Here is where things get genuinely surprising, especially for anyone who assumed the deep roots of Punjab traced back primarily to migrants sweeping in from the vast grasslands of Central Asia. The Rakhigarhi woman carried zero detectable ancestry from steppe pastoralist populations. None at all. That absence turned out to be enormously significant, because a large wave of migration from the Eurasian steppe has long been associated with the spread of Indo-European languages, cultural practices, and, according to some traditional narratives, the earliest ancestors of many communities across northern India and Pakistan. If the people who built the Indus Valley civilization carried no steppe ancestry whatsoever, that meant something important. Whatever role steppe migrants eventually played in shaping the region, it did not happen during the height of this earlier civilization. It happened afterward. So when exactly did steppe ancestry actually arrive in the region we now call Punjab? Researchers analyzing burial sites in the Swat Valley, located in what is now northern Pakistan, found the answer buried directly in the bones themselves. Steppe-related ancestry does not show up in South Asian burials until roughly 1,200 years before the Common Era. That places its arrival well after the decline of the Indus Valley civilization, which had already begun fading by around 1,900 years before the Common Era. In other words, there is a real gap of several centuries between when the great Indus cities collapsed and when steppe ancestry actually shows up in the archaeological and genetic record. This timeline lines up with a much larger, well-documented pattern of ancient human migration. Populations connected to the vast Eurasian steppe, stretching from Eastern Europe all the way through Central Asia, expanded rapidly during the Bronze Age. These groups are genetically linked to the broader Yamnaya cultural sphere, a population whose descendants also spread deep into Europe around the same general period, carrying related ancestry, and many researchers believe related languages as well. In fact, when steppe pastoralist groups eventually made their way into South Asia, they carried a distinctive genetic signature, one that mixed cleanly with the populations already living across the region, including the descendants of the people who had built the Indus Valley cities centuries earlier. Quick pause here. If this kind of deep history genuinely fascinates you, go ahead and hit that like button right now. It helps push content like this in front of more people who care about where we actually come from. Modern Punjab sits at the very center of this ancient genetic story, and the evidence shows up clearly when scientists study the Y chromosomes of Punjabi men today. A specific genetic marker, known scientifically as R1A, specifically a branch labeled Z93, appears at remarkably high frequencies across Punjab, ranging anywhere from roughly a quarter to nearly half of the male population, depending on the specific community studied. This is actually the highest concentration of this particular lineage found anywhere across the entire South Asian subcontinent. Researchers trace this genetic branch directly back to Bronze Age populations connected to the Central Asian steppe, specifically cultural groups associated with regions historians call the Sintashta and Andronovo complexes. This single genetic marker offers a direct, traceable link between many Punjabi men alive today and steppe pastoralist migrants who arrived in the region thousands of years ago. But here is the part that genuinely surprises most people. Steppe ancestry, while significant, is only one thread woven into a much larger genetic tapestry. Modern Punjabis are not simply descendants of steppe migrants who replaced everyone who came before them. They are a genuine blend, carrying meaningful proportions from all three major ancestral populations that shaped the broader region over thousands of years. That means ancient hunter-gatherer ancestry, connected to the earliest inhabitants of South Asia, ancient Iranian-related farmer ancestry, connected to the builders of the Indus Valley civilization, and steppe pastoralist ancestry that arrived later during the Bronze Age, all show up together in the DNA of people living in Punjab today. No single ancestral group tells the complete story on its own. What makes this discovery even more remarkable is what it reveals about shared ancestry across the entire subcontinent. Researchers have found that essentially every population studied across modern South Asia, stretching from Kashmir in the far north down to Kerala in the deep south, carries meaningful genetic contributions traced back to the people of the Indus Valley civilization. That includes communities that look, sound, and live completely differently from one another today. In a very real sense, the ancient builders of those remarkable Indus cities are shared ancestors connecting an enormous portion of the modern population across the entire region, regardless of the language someone speaks or the religion someone practices today. This finding touches on one of the most debated and genuinely sensitive topics in the study of South Asian history. For well over a century, scholars have argued about exactly how Indo-European languages, including the ancestor language behind Punjabi, Hindi, Sanskrit, and dozens of other regional languages, actually arrived and spread across the subcontinent. Some traditional narratives held that these languages, along with associated cultural and religious traditions, developed entirely within South Asia itself, with no significant outside migration involved at all. The ancient DNA evidence tells a more nuanced story. It confirms that a genuine migration of steppe-related populations did occur, arriving centuries after the Indus Valley civilization had already declined, and that this migration likely played a meaningful role in spreading Indo-European languages across the region. At the same time, the evidence firmly establishes that this migration built directly on top of a much older, already well-established population, rather than replacing it entirely. Both things turn out to be true at once, which is honestly far more interesting than either simplified version of the story on its own. It is worth pointing out that this particular area of research has occasionally become entangled with modern political debates, especially within India, where interpretations of ancient migration carry weight far beyond pure academic interest. Some public figures and portions of the media have, at times, presented individual genetic studies as definitive proof supporting one particular version of ancient history over another. Most researchers actively working in this field caution against that kind of oversimplification. A single ancient genome, even one as significant as the Rakhigarhi discovery, refines and adds crucial detail to the bigger picture, but it does not single-handedly overturn decades of accumulated evidence from linguistics, archaeology, and broader population genetics. The honest scientific picture is layered and complex, built from multiple independent lines of evidence that increasingly point toward the same general conclusion, even while researchers continue debating specific details. So, what does all of this actually mean if you are Punjabi, or if your family traces its roots back to that region? It means your ancestry is genuinely layered, stretching back through multiple distinct waves of human history that most people never learn about. Deep within your genetic code sits ancestry connected to hunter-gatherers who lived across South Asia long before agriculture existed anywhere in the region. Alongside that sits ancestry connected to the brilliant urban planners and traders who built some of the most advanced cities of the ancient world along the banks of the Indus River. And layered on top of both of those ancient threads sits ancestry, connected to pastoralist migrants who arrived from the distant Eurasian steppe, bringing new languages, new cultural practices, and new genetic diversity into a region that had already been inhabited and thriving for thousands of years before their arrival. This layered, blended ancestry is not unique to Punjab, of course. Nearly every population on Earth carries a similarly complex genetic history once scientists take the time to actually dig into it using ancient DNA. Populations across Europe carry their own complicated mixture of hunter-gatherer, early farmer, and steppe pastoralist ancestry, following a strikingly similar general pattern to what researchers found in South Asia. What makes the Punjab story particularly compelling is simply how clearly and precisely scientists have now been able to trace each individual thread, thanks to a combination of extremely well-preserved ancient remains, cutting-edge sequencing technology, and an enormous number of modern genetic samples available for comparison. If you are finding all of this as fascinating as I do, go ahead and subscribe to this channel. We cover genuinely mind-blowing anciency, history and genetics, content like this on a regular basis, and you will not want to miss what comes next. It is worth taking a moment to actually picture what these ancient people looked like, since researchers have gone beyond raw genetic data and attempted full facial reconstructions, using skeletal remains recovered from Rakhigarhi. Scientists studied dozens of individuals buried at the site and successfully reconstructed detailed facial approximations for a small handful of them. These reconstructions offer a genuinely striking glimpse into the faces of people who lived and died in the region more than 4,000 years ago, long before anyone recorded their names, their languages, or their beliefs. Seeing an actual reconstructed face connected directly to ancient DNA data adds a powerful human dimension to what might otherwise feel like abstract genetic percentages and statistical estimates. The genetic story also becomes noticeably more intricate once researchers zoom in on specific communities within Punjab itself, rather than treating the entire population as one uniform group. Different Punjabi communities, including groups historically associated with distinct social and occupational roles, show measurable variation in exactly how much ancestry they carry from each of the three major ancestral streams. Some communities carry proportionally higher steppe-related ancestry, often correlating with historical social status and position within traditional community structures. Other communities show a stronger genetic signal, connected to the earlier hunter-gatherer populations, who inhabited the region long before either the Indus Valley civilization or the later steppe migrations occurred. This internal variation actually reinforces the broader point rather than complicating it. Punjab was never genetically uniform, even within its own regional boundaries, and the layered migration history researchers have uncovered left distinctly different genetic fingerprints across different communities living side by side within the same geographic area. This kind of detailed community-level analysis has only become possible recently, thanks to a dramatic drop in the cost of genome sequencing technology combined with growing interest in consumer genetic testing across South Asia. A decade ago, running this level of detailed genetic analysis across dozens of distinct communities would have been prohibitively expensive and technically difficult. Today, researchers can compare thousands of modern genetic samples against ancient, reference genomes with remarkable precision, revealing patterns that remained completely invisible to earlier generations of scientists working with far more limited tools and far smaller sample sizes. Beyond Punjab specifically, this broader pattern of layered ancestry helps explain a puzzle that anthropologists and linguists have wrestled with for generations. Northwest South Asia, the region covering modern Punjab and its surrounding areas, has always shown a noticeably different genetic and linguistic profile compared to communities living further south, and east across the subcontinent. Ancient DNA now provides a clear evidence-based explanation for that long-observed difference. Communities living closer to the historical entry points for steppe migration naturally absorbed a higher proportion of that later ancestral wave, while communities living further away, geographically insulated by distance and terrain, retained proportionally more of the earlier hunter-gatherer and Indus Valley-related ancestry. Genetics, geography, and history all line up together here, painting a remarkably consistent picture once you actually connect all the available evidence. There is also something deeply humbling about discoveries like this one. For thousands of years, entire communities built their sense of identity around specific stories of ancient origin, often passed down orally for countless generations before anyone wrote them down. Ancient DNA does not necessarily erase those stories, but it does add layers of nuance and detail that nobody could have possibly known before modern genetic sequencing technology existed. It turns out that the true story of where Punjabis came from is far richer, far older, and far more interconnected with the rest of South Asia, and even Central Asia, than most people ever imagined. Rather than one single unbroken ancestral line stretching back into the distant past, the real picture looks more like a river formed from multiple distinct tributaries, each one flowing in from a completely different direction, eventually merging together to form the population living across Punjab today. Scientists are not finished uncovering this story either. Ancient DNA research across South Asia is still a relatively young field compared to similar research already completed across Europe, largely because of the technical challenges involved in extracting usable genetic material from remains buried in hot, humid climates. Every successful extraction, like the landmark sample pulled from Rakhigarhi, opens the door to sequencing additional ancient individuals from sites across Punjab, Pakistan, and neighboring regions. Each new genome adds more precision and detail to the overall picture, refining exact migration timelines, clarifying how different ancient populations mix together, and potentially uncovering entirely new ancestral threads that nobody has identified yet. Researchers involved in this field have also emphasized just how much this specific discovery reshapes our understanding of how agriculture and complex ideas actually spread through the ancient world. The genetic evidence suggests farming likely developed in South Asia through a slow process of cultural transmission and local innovation, rather than arriving suddenly through a large wave of migrating farmers from the Middle East, as some earlier theories had proposed. That distinction matters, because it suggests the ancient people living across the Indus region were not simply passive recipients of outside ideas. They were active participants in developing their own sophisticated agricultural and urban systems, using knowledge that spread gradually through contact and exchange with neighboring populations, rather than being handed to them wholesale by outside migrants. Put all of these threads together, and the modern genetic story of Punjab becomes something far more compelling than most people ever learned growing up. It is not a story of one single ancient people staying isolated and unchanged for thousands of years. It is a story of deep hunter-gatherer roots stretching back tens of thousands of years, layered together with the genius of Bronze Age city builders along the Indus River, further layered with pastoralist migrants arriving from the distant steppe centuries later, all blending together over countless generations into the population living across the region today. Every single person with roots tracing back to Punjab carries fragments of that entire layered history sitting quietly inside their own DNA, whether they ever knew it or not. That is the real power of ancient DNA research. It does not simply confirm what people already assumed about their own history. It frequently reveals connections nobody could have predicted, tracing threads across thousands of years and thousands of miles, linking modern communities to ancient populations who lived, farmed, built cities, and eventually migrated across landscapes long before anyone wrote a single word of recorded history. The Punjabis were never just one simple story passed down through generations. They were always a blend, a genuinely ancient mixture of hunter-gatherers, city builders, and steppe migrants. And thanks to modern science, that hidden layered history is finally being written back into the record, one ancient genome at a time.